In this video, I'll show you how to convert verbal statements into algebraic equations. This is part 3 of the series. The question asks, how many tons of chromium must be added to 2.5 tons of steel to raise the percent of chromium from 11% to 18%? What we have is a mixture of metals, one of which is chromium, and another metal that is forming stainless steel. Currently, 11% of the 2.5 tons is chromium. So 11% of 2.5, which can be mathematically represented as 0.11 times 2.5. Let's use our calculator. 0.11 times 2.5 gives us 0.275. So 0.275 tons is equal to the amount of chromium in this stainless steel. We're asked how much more should be added to 2.5 so that this goes from 11% to 18%. And to do this, we'll write down x plus 0.275, which is the amount of chromium originally, while this x represents the amount of pure chromium added, and it has a concentration of 100%, hence the 1 coefficient which is not shown. So we have 100% of unknown chromium mass added to 0.275 tons. And this equals to 18% of 2.50, which was the original mass plus the unknown x. Now all we have to do here is solve for x. We use the distributive law to multiply this, and we have 0.18 times 2.50, and that gives us 0.45 plus 0.18 x. On the left side, this stays the way it is. Collecting like terms, we end up with 0.275 minus 0.45 is equal to 0.18x minus x. Using our calculator from here, we'll combine these two. So we have 0.18 minus 1, negative 41 over 50, x. And on the left side, we have 0.275 minus 0.45 divided by this number, and we end up with 0.2134. 0.2134 tons. So let's analyze this for a second. We will need 0.2134 tons to raise the percent of chromium from 11% to 18%. And our final volume would be 2.50 plus 0.21, and this would give us 2.71 approximate tons for this to be achieved. And so there you have it. That is how to convert verbal statements into algebraic equations.